Unit 2 Chemistry, Chapter 13, Part 1. Now we're looking at water as a solvent and how it acts in that. Okay. So, if mixtures mix, then that essentially means there's a force of attraction between the solvent, the thing you're dissolving it in, and the solute, the thing you're trying to dissolve. Okay. These will be a type of intermolecular force. So it could be an ionic bond, a dipole-dipole attraction, a hydrogen bond, or a dispersion force. Okay. Basically, a non-polar substance can dissolve other non-polar things, and a polar substance can dissolve polar things or ionic substances because it's charged, so it's dissolving based on charge attractions. Water, being polar, can dissolve polar covalent compounds that it makes hydrogen bonds with, polar covalent molecular things that actually turn into ions, and we'll look at what those are later, and ionic compounds that are charged. So it's a really wide range of substances, and that's such a good solvent. So when we talk about dissolving, what we're actually meaning is with making a solute go into solution. The solution is homogeneous, which means you can't see different layers to it. If you mix it together, it doesn't then later separate out. And the particles that are dissolved, you can't see them. They're too small to see. So to think about why things do dissolve, it's sometimes useful to start by thinking about the opposite, why oil and water don't dissolve. So if you take oil and water and you mix them together and you give it a good stir, you can make some separation between them. And you can make them sort of look like they've mixed, but if you leave it, they're going to separate out. They're going to separate out because this negative dipole is going to be attracted to that positive dipole. So it's going to push that oil particle out the way. And then this one, the same thing. So they're going to push this one a bit out of the way. And this is going to be attracted to that. So they're pushing that one out of the way. And when they push them out of the way, because oil is less dense, it goes to the top. Okay? So the forces of attraction mean that they're going to be attracted more to each other than to the oil because they could only make dispersion forces with the oil, which is nowhere near as strong. Okay, so when things do dissolve, it means that they do have a force of attraction between them, which is strong enough to overcome those attractions between one water molecule to the other. So if salt dissolves, for instance, the water molecule is attracted to the cations and the anions, which disrupts the lattice. Okay, so this would be our sodium chloride together, and what we can have is the sodium and the chloride ions being separated, and each one being surrounded by water, and that's a state that we call being hydrated. Okay, and these other water molecules are ready to take another one off the lattice. So we've got some key steps. The first thing is we've got to separate the particles of the solute from one another. Secondly, we've got to separate the particles of the solvent from one another. And then we have to attract the solvent to the solute. And if those bonds between the solvent and the solute are stronger than the bonds that were holding the solute together and the bonds that were holding the solvent to each other, then we're going to get dissolving occurring.